Static reaches the speakers first. Dry, uneven, moving in slow layers across the receiver room like dust scraping through the walls. Then a pulse pushes through the noise for less than a second before tearing apart again. The line never disappears cleanly. It trembles. A thin green trace flickers across the monitor while the carrier frequency struggles to hold lock. One moment, the signal sounds distant but intact. The next, sections collapse beneath dense bursts of interference sharp enough to force the system to reacquire the transmission entirely. Voyager is still talking. Something between the probe and Earth keeps reshaping the voice on the way home. Static reaches the speakers before the voice does. Not loud, just uneven. A dry layer of interference moves across the receiver room in thin bursts, like something scraping through dust far beyond the walls of the solar system. Then a signal pushes through it for half a second and tears apart again. The line does not disappear cleanly. It shivers. NASA still receives transmissions from Voyager 1 beyond the heliopause. The signal has been crossing interstellar space for nearly a full day before it reaches Earth. The signal leaves the spacecraft clean. By the time it reaches Earth, sections of it no longer match what was sent. Charged plasma drifts through interstellar space and bends radio waves as they pass through it. The transmission arrives damaged. A thin green line flickers across the monitor under rising static. Sections bend sideways. Small gaps open inside the data stream where information should still exist. Distance alone should weaken the signal smoothly. Instead, sections return distorted in ways engineers cannot fully predict. Out there, nothing shields the transmission from radiation before it crosses back toward Earth. Electronics slowly lose reliability that far from any planetary protection. Small transmission errors begin stacking faster than the system can fully correct them. The sound keeps breaking apart. A signal still trying to hold its shape after crossing billions of miles of exposed space. The static keeps moving after the transmission ends. Not outward, sideways. Bands of interference slide across the signal path in slow waves, breaking the transmission differently each time it passes through. One section clears, another fills with noise again. The distortion no longer stays in one place. In 2012, Voyager crossed the heliopause, beyond the strongest reach of the sun's protection. There is no visible border there. Protection just thins gradually into exposure until the spacecraft enters a region where solar protection stops feeling reliable. The sun is still behind it, just too distant for its protection to remain stable. Charged particles strike the probe constantly now. Radiation passes through exposed electronics for years at a time. Small onboard systems begin resetting more frequently. Telemetry drifts. Heat control weakens. The signal arrives carrying damage from the trip itself. A human body exposed there would deteriorate slowly under constant radiation exposure. Vision would blur long before death arrived. Cooling systems inside a suit would struggle to compensate. There is no atmosphere there to absorb the exposure first. The radiation reaches everything directly. The line trembles again beneath the static. The sun no longer covers it. The pulse keeps deforming long after the spacecraft sends it. Hour after hour, the transmission moves through a region that looks completely black from a distance. But the region between Voyager and Earth behaves less predictably the farther the signal crosses it. Thin plasma drifts between the stars in uneven concentrations, and the radio pulse bends slightly as it crosses through it. The distortion stays invisible at human scale. The transmission still arrives altered. A message sent from Voyager 1 can take nearly a full day to reach Earth, depending on relative position. During that time, the transmission crosses billions of miles of charged space. Small fluctuations accumulate across the journey. Some sections arrive weaker than others, as if the transmission has been unevenly worn down during the crossing. For a moment, the damage almost feels understandable. The signal weakens because the journey itself keeps interacting with it. Empty space is not empty here. Every additional hour inside interstellar space gives the distortion more time to accumulate. Tiny charged particles drift across the transmission path constantly. Not enough to stop the message, enough to roughen it. A faint pulse moves through uneven plasma concentrations that scatter parts of it along the way. Human equipment would begin failing long before the environment looked dangerous. Communication would distort first. Navigation timing would drift. Electronics exposed too long would begin failing in small, unpredictable ways. The static rises again in short bursts. Somewhere inside it, the original signal is still trying to hold its shape. The transmission clears for almost 3 full seconds. No tearing, no drifting distortion. The line stabilizes across the monitor so cleanly that the earlier explanation finally seems believable. A weak transmission crossing charged interstellar space. The damage finally seems measurable. Then the pattern changes again. Static folds across the signal midline in a denser pattern than before. Not gradual interference this time. A sudden burst. Dense, jagged. The clean transmission collapses under it so quickly the receiver software loses lock on the carrier frequency. Nothing about the route should have changed that fast. Voyager 1 barely moves relative to the scale around it. Yet the environment between the probe and Earth keeps shifting anyway. Plasma density shifts across the route unpredictably. Radiation exposure rises and falls without staying stable long enough to model cleanly. The distortion no longer repeats in stable patterns. That is the part that starts affecting survival planning. A human crew, depending on stable shielding, would slowly lose confidence in every protection model they built. One exposure region weakens, while another intensifies somewhere else along the route. Electronics calibrated for one exposure condition begin failing under a different one without warning first. Understanding the environment does not make it predictable. A clean signal vanishes again beneath moving static. For a few seconds afterward, the receiver room only carries noise. The noise thins just enough for the signal to escape again. A weak pulse separates from the static and continues outward across black space, still moving long after Earth stops hearing it clearly. Behind the transmission, Voyager 1 keeps moving farther from the Sun, while its remaining power slowly declines each year. The spacecraft is still operating, but only partially. Small systems shut down one by one to preserve energy. Heat fades from unused instruments. The signal leaving the probe grows weaker, while the environment around it keeps shifting unpredictably. The machine still transmits. The journey decides how much survives. Beyond the heliopause, the Sun no longer dominates the environment around Voyager. It survives inside a region where radiation continues crossing the transmission path long after the message leaves the spacecraft itself. By the time the transmission reaches Earth, nearly a full day of exposure has already altered parts of it. And even then, only fragments survive cleanly. A human body could not remain functional there indefinitely. Shielding would slowly absorb cumulative damage until protection models no longer matched the environment around them. Cooling systems would weaken. Communication delays would force crews to react to conditions that had already changed before responses arrived. The message is still crossing, Somewhere beyond the solar system, a room-sized machine continues moving forward, while fragments of its voice keep breaking apart on the way home.